All right. We need to learn how to do vector addition. There's a few steps involved for being able to do this. And first thing we need to know, this is basic like trigonometry stuff here. That's why you did some trig review for this. When you have a vector, that vector is going to have some magnitude. I'm going to call that r. That's like how long this arrow is. And it's going to have a direction. That's theta. And that's going to be from horizontal, right? Imagine a y-axis there too if you like. Now what we need to be able to do is take that vector and break it up into its x part and its y part. Oops, want to make that a dotted line. What's the big deal with the dotted lines, you might be thinking? Like, do I really need to bother with that? And I would like you to try to bother with that, please, because I don't want to, like, there's two different ways. You could think of it this way, like you're giving somebody directions. If you're trying to get to here, there's two different ways you could do, well, there's lots of ways you could do it, but there's two possible ways you could do it are start at the origin and go this far in this direction. And then you get to here, right? And then another way is start at the origin and go this far over and this far up. Right? Now you've been trained in math classes to think about locations on the xy plane more like this. Right? Over and up, xy. In the real world, like if you're standing in the middle of a field and you're trying to tell somebody like go over to this place and there's nothing in the way, like not like streets that only go this way or something like that, you're not going to tell them to do this. You're just going to tell them like, okay, point in this direction and go straight there. So anyway, we want to make these dotted lines because they're not like extra vectors of this. It's like a this or this. We don't want to give the impression that there's like three different vectors going on. It's this one or these alternative is the dotted lines. So try to do the dotted lines, please. I'm not going to fuss at you too much if you don't. So what's the relationship between all the stuff here? Well, the Pythagorean theorem says that x squared plus y squared is equal to r squared. And then I know some sine relationships too. So let me just write those down. I know that x squared plus y squared is equal to r squared. That's true. And I know that the sine, let's do cosine first. The cosine of theta is equal to, cosine is adjacent over hypotenuse. And the sine of theta is equal to opposite over hypotenuse. And also, it's going to come in handy for us. Tangent of theta is equal to y over x. So there's the Pythagorean theorem and the three main trig functions. Excuse me. Okay, so there's two different ways that you could have the directions to get from here to here. In other words, that you could have a vector. Either you're going to get the direction and the magnitude, the theta and the r, or you're going to get the x and the y. We need to be able to move back and forth between those. So if you have x and y, and you want r and theta, then what do? Well, you got to have r equals something and then theta equals something, and this has to be with x and y, because you got x and y and you want to try to figure out what r and theta are. Well, everything that we need is here. If you want r and you have x and y, then that's your ticket right there. You want to do the square root of x squared plus y squared. If you have x and y and you want to know what theta is, this is the equation right here that has theta and x and y. So you need to get theta out of that trig function. That's when we do the inverse. So it's tangent inverse y over x. So that's how you get r and theta if you have x and y. And come assessment time, this is something that I think I would allow you to have in your notes. So just in case you're not writing this stuff down, you are a student, so you take notes. So what if you have r and theta, and you want the xy? Okay, so that means I need to have an x equals and an y equals, and then on this side, if I have r and theta, it's got to be r and theta. So here's an equation here. If I just multiply the r up to that side, x is equal to r cosine theta, and y is equal to r sine theta. Okay. Now, I'm going to do a problem for you, and in the course of doing that example problem, I'm going to use all of this stuff, and the example problem is basically going to be like the hardest version of the kinds of problems that you're going to see in the next few assignments. So just be warned that some of the problems I'm going to give you do not involve all of the steps that I'm about to do. They only involve some of them, and maybe well, I'll talk about that in the when I do those assignments and like post the videos of those assignments for you. Okay, so here's an example. This example is very important. This doesn't mean it should not go in your notes. This absolutely needs to be in your notes. We're going to try to add two vectors. Say the vector A. When we have a variable vector, we put a little vector hat on it, a little arrow on top of it to show that it's a vector. So let's say vector A is equal to 3, and sometimes when we write vectors, we do them in unit vector notation, which just means that we have like an x component and a y component, and just to keep them separate from each other, we do like 3i plus 4. Oh, you know what? I'm not going to do that. I'm getting confused with the way we do things in AP Physics, and we're not going to do that unit vector notation. It's not that hard. You guys can totally handle it, but we just do some things a little bit different here. So let's say vector A is equal to, that it has a magnitude, which means that's the r, equal to, let's say, 5 meters, and the direction is 30 degrees in the first quadrant. And let's say that vector B has a magnitude of 6 meters and a direction of, how about 45 degrees in quadrant 2. When you're given directions, unless it explicitly says otherwise, you're going to assume that the that angle is measured from horizontal. So in other words, when remember your quadrants, right? This is quadrant 1, 2, 3, 4. So if it says 30 degrees in quadrant 1, that 30 degrees is measured up from that axis. When we say 45 degrees in quadrant 2, that 45 degrees is measured up from that axis. Always measured from horizontal. We don't measure from the ups and downs. So you want to be in quadrant 3, then you describe the angle. How far do you have to go from here? How far do you have to go from here? Okay? Oops, can you see that? I'm sorry. Let me, just in case that was cut off there. So we're always going to measure our angles from horizontal, right? From the x-axis. So moving up to here, moving up to here. All right, so that's not a bad picture of what these two might look like. That has a length of 5, that has a length of 6. So I want you to add those two together, or I'm going to add them together. And you're like, oh, that's easy, man. 5 plus 6 is 11. You almost, I mean, if you got like 10 fingers plus a pencil, you can do that. And then the direction, let's see, I'll just add those together. That's 75 degrees, and then, I don't know, I'll just pick a quadrant. How about 1? Well, that's totally wrong. It just doesn't work that way. What it means to add vectors together, it's like if you think back to this example of like giving somebody directions, like go from here to here. If you add another vector, that's like telling them a new direction and distance to go. So when you add 2 vectors, it's like doing this one and then like plus whatever this one is. Like reset, pretend that's the origin, and do the other one. So we're going to end up somewhere like up here, kind of near that y-axis. And the length is not going to be 11. It's going to be definitely less than 11. If you had 2 vectors and they were going in exactly the same direction, then you would add those, right? But if there's any difference in the directions, then it's going to be less than whatever those add up to. Okay, so how the heck are we supposed to do this? I'll show you. First thing we need to do is break the a and the b vectors. We have the r and the theta, and what we want to do is get the x and the y. Okay, so here, I'm going to make a little chart. Here's my x's, here's my y's, here's vector a, and here's vector b. So to get this right here, for vector a, to get the x, I need to do r times the cosine of theta. R times the cosine of theta. 5 times the cosine of 30. So I'm going to do that on my calculator here. Please make sure that your calculator is in degree mode before you start punching any buttons on it. 5 times the cosine of 30. I'm going to round to the nearest tenth. Don't be writing down all those numbers on your calculator. So this is 5. I'll go ahead and write that down. 5 cosine 30, which is 4.3. Okay? Should it be positive or negative? Well, I'm in the first quadrant, so that x is going to be positive. Okay? How about the y part of that? Well, that's 5 sine 30. And that's 2.5. And that should be positive because I'm in the first quadrant. Okay? How about the b vector? So I got 6 times the cosine of 45. Let's see, that's an x-coordinate in the second quadrant. X-coordinate in the second quadrant. That needs to be negative. I'm going to put the negative sign here and put a negative sign in front of that, so they are, in fact, equal to each other. So let's see, 6 times the cosine of 45 is about 4.2. And here I've got 6 times the sine of 45. It's a 45-degree angle, so you can punch that in your calculator. It's equal to the same thing. That's a y-coordinate in the second quadrant. That's positive. Okay, this is the number one thing that my physics students in the past have struggled with, is paying attention to what these signs are. If you go through this and you're like, yeah, man, I don't really care about physics, I'm just like crashing through, hoping I can finish this assignment, you know, whatever, you're going to make a sign mistake. You have to pay attention, and if you're like, but Mr. McGrath, I actually don't care about physics, well, okay, settle down. Listen, just pretend that you care. If you pretend, and you're like, yes, I am actually trying to be a good student, pay attention to all those details, then you'll be fine. You know, who's to say, like, what's really the difference between, like, pretending to care and actually caring? Is there a difference? I don't know. So, what do you do then? Okay, so then you make your totals here. So, here's my x total. I have 4.3 and negative 4.2, so just add those up. That gives me 0.1 in the x direction. And then add these up. They're both positive. That gives me 6.7. This is your x total and your y total. And then, I mean, that's the answer, right? The answer is a vector that has like an x component. That was right when we did this, so like it goes over just a tiny bit and then up. That's what happens if you add this and that. So now we got to put them back together, and so now we have an x and a y, and we want to have the r and the theta. So here, how do you find the r? You do this. You know what this is going to be equal to? Probably 6.7, because this is really, really small. So you can put that in your calculator, but I bet you a big pile of money that if you round to the nearest tenth, that you're just going to get that. Here, let's do it, just to be sure. Oh yeah, that barely made a difference. Okay. And how about the direction? The direction is tangent inverse y over x and this should be an angle. It should be like in the high 80s, right? It's like right up there, up against the axis. Let's see what it is. Tangent inverse y over x, 6.7 over 0.1. Oh yeah, 89 degrees. All right, what quadrant is it in? Well, just look at your totals. This is positive, positive. Positive, positive gets you into quadrant 1. Negative x, positive y is quadrant 2. Negative x, negative y is quadrant 3. Positive x, negative y is quadrant 4. So that's how you add two vectors together. Now, just be careful in the first 5 problems that you're going to do on this vector sheet 1 or whatever I'm going to call it. You don't have to do all of this until like maybe number 5. So just be careful. Like if all it says is break them up into the x and the y components, then that's all you need to do. So this is as much as you ever need to do. This is given vectors in their magnitude and direction form. You got to break them up, find the x and y totals, and then put them back together again. That's the most that you ever have to do. All right, that was fun.